So hopefully, ladies and gentlemen, we came up with 6x squared plus 2y times dy dx is equal to 3 dy dx. Any questions on how I differentiated the equation using implicit differentiation? Okay. Now it's asking me to find the value of the derivative of x equals 1. So again, this is where I said you don't, since I'm going to evaluate this derivative at a particular value, you don't need to solve for dy dx. You can plug the numbers in and then worry about solving for dy dx. The problem is I know my x value. I know it's when x is equal to 1. But to evaluate this derivative, what do you also have to know? You have to know the what? The y-coordinate. So how am I going to find the y-coordinate? I have to plug 1 back into my original equation for x. So I have 2 times 1 to the third plus y squared is equal to 3y. How am I going to solve this equation? Factor. It's quadratic equation. So again, I need to get a 0 on one side. So 2 times 1 to the third is 2. So up with y squared, I'm going to subtract my 3y plus 2 is equal to 0. So when I factor this, I end up with y minus 2 times y minus 1. So what's y going to be equal to? Y is equal to what? 1 and 2. So what happens, you've got two different points on this curve where x is equal to 1, just like I showed you with the circle. You have a point at x equals 1 and y equals 1. You also have a point at 1, 2. So whatever this curve looks like, you're going to have two different points. Again, these are not functions. A lot of these are not going to be functions. They fail your vertical line test. So what it means then is we're going to evaluate this derivative at both points. So let me do the 1, 1 first. So at 1, 1, I'm going to plug 1 in for x and 1 in for y. So 6 times 1 squared plus 2 times 1 dy dx is equal to 3 dy dx. So that gives me 6 plus 2 dy dx is equal to 3 dy dx. How are you going to solve this? Any thoughts? Remember, what are you trying to solve for? Whether you're using the y prime notation or whether you're using the dy dx. Kate?
You could subtract 2 dy dx and then factor it out.
Or aren't these like terms?
Yep.
So if you use y prime, so what is this? So what is the dy dx going to simply be equal to? 6. So just like it was a 3y prime minus a 2y prime, you're done. I mean, if you want to factor it out, go ahead, Kate. Go ahead. You're a factoring queen. All right, so any questions on how I found? So the value of the derivative at the point 1, 1 is going to be 6. Okay? So now we have to check 1, 2. So then at 1, 2, we have to do the same thing. Plug 1 in for x, plug 2 in for y. So I have 6 times 1 squared plus 2 times 2 dy dx is equal to 3 dy dx. So up with 6 plus 4 dy dx is equal to 3 dy dx. So what is the value of the derivative going to be at the point 1, 2? Negative 6. So at 1, 2, notice you end up with a negative slope. At 1, 1, you end up with a positive slope. So now let's read part B. Find the equation of the tangent line at x equals 1. Again, anytime you need the equation of a tangent line, what two things do you have to know? You have to know the point, you have to know the slope. So in this particular case, you've got 2 points. So guess how many equations you're going to have to write? 2. So at the point 1, 1, what did we come up with the slope to be? The slope was equal to what? 6. At 1, 2, what did we come up with the slope to be? Negative 6. So I end up with y minus 1 is equal to 6 times x minus 1. There's one possible equation. There's one equation of your tangent line. And then the second equation will be y minus 2 is equal to negative 6 times x minus 1. So part C. Find the equation of the normal line at x equals 1. What does it mean to be normal? What type of lines are we looking at? Perpendicular. So again, at the point 1, 1, we had a slope equal to 6. So for the line perpendicular to 1, 1, what's the slope going to have to be? Negative 1, 6. at the point 1, 2, we had the slope of negative 6. So to be perpendicular to this, what's the slope going to have to be? 1 over 6. So in the equation, I'll have two different lines that I have to write. So I have y minus 1 is equal to negative 1, 6 times x minus 1. I also have y minus 2 is equal to 1, 6 times x minus 1. So for part D, so again, now we're trying to find the points on the graph where the tangent line is horizontal. So to find your horizontal tangent line, what do we want the derivative to be equal to? The derivative will have to be equal to what? 0, exactly. So this is again where your y prime is equal to 0. So now we already know what the derivative looks like. 6x squared plus 2y dy dx is equal to 3 dy dx. Now you have no choice. You're going to actually have to solve for dy dx. So just like I did a few minutes ago, you've got more than one term that has a dy dx in it. You want to gather all your terms that have a dy dx in it. So I'm going to subtract the 2y dy dx. Now that everything on the right-hand side contains a dy dx, this is where now I'm going to factor it out. There you go. So we have 3 minus 2y. Now how are we going to get dy dx by itself? We're going to have to do what to both sides? Divide by 3 minus 2y. So dy dx is equal to 6x squared over 3 minus 2y. Great. So this is where you told me that I want a horizontal tangent line, so this is where I want my derivative to be equal to 0. So now I need to take this fraction and set it equal to 0. Well, when a fraction is equal to 0, the 0 would be coming from what? The numerator or the denominator? Numerator. So that's why this hint tells you, so set the numerator of y prime equal to 0. So I'm going to set 6x squared is equal to 0. So what's x going to be equal to? 0. Is that my answer? No. Point. Some of you made that error on the quiz. You left your answer like this, but the directions ask for points. Make sure you are always going back. I cannot emphasize this enough. Go back and reread the original question. Make sure you're answering the question, because some of you made that error on the quiz. All right. So now, how do I find the y coordinate here? Where do I plug it back in? To the original equation, exactly. So I have to plug it back into the original. You're always finding points back on the original curve. The derivative is just used for slope. So when I plug 0 back into my original equation, I have 2 times 0 to the third plus y squared is equal to 3y. How do I solve it? So I ended up with just y squared is equal to 3y. Never, ever, ever divide out the variable you're solving for. You don't divide out the y. How are you going to solve this? What kind of equation it is? Say what? Quadratic. So all your quadratic equations, what do you want to get on one side of the equation? You want to get a 0. So y squared minus 3y is equal to 0. Now how do you solve it? Factor out a what? Y. So y minus 3 is equal to 0. So what's y going to be equal to? 0 and 3. So you have two places where you're going to have horizontal tangent lines. At x equals 0, one of them will have a y value of 0. So you have the point 0, 0. At x equals 0, you also have a y value of 3. So there's your answer. Yes?
Up like right when you got the 0, where it has the arrow going from 6x squared, what's the point of that? Didn't you just write the same thing? Like 6x squared over 3 minus 2y, and you put the arrow to 6x squared over 3 minus 2y.
I just showed where I divided it, that's all.
Okay.
I just showed why I actually solved for dy dx. I just kind of moved because I ran out of room.
No, below that, the little.
Right here?
To the right. Like where you.
I just set it equal to 0. This one wasn't set equal to 0. I just wrote set equal to 0. All right? So any questions on that one? So it's the same kind of questions, but now you're having to be on that lookout. You may have more than 1 point. So let's take a look at E. Find all the points on the graph where the tangent line is vertical. Well, vertical lines have what kind of slope? It's where the slopes are what? Undefined. So this is where your derivative is undefined. So here is my derivative. There's my dy dx is equal to 6x squared over 3 minus 2y. Well, what makes a fraction undefined? It's when what is equal to 0? Denominator. So this is why you're going to set the denominator of y prime equal to 0. So I have 3 minus 2y is equal to 0. So what's y going to be equal to? Y would be equal to what? 3 over 2. Subtract 3, divide by negative 2. Is that my answer? No, because what's it asking me for? Points. How do you find the x values? You're going to have to do what? Plug it back into the original. But now this case, I already know the y value. What are you actually going to be solving for? You're going to be solving for not y this time. You're going to be solving for what? X. Because this case, we actually know the y coordinate. So we have 2x to the third plus 3 halves squared equals 3 times 3 halves. So I have 2x to the third plus 9 fourths is equal to 9 halves. How do you solve this one? If you don't like working with fractions, could you get rid of the fractions in the equation by multiplying everything by the LCD? Yeah, so if the remember, you have that LCD trick. So when you're solving these equations, if you end up with fractions, use that LCD trick. What could you multiply this entire equation by? 4. So I end up with 8x to the third plus 9 is equal to what? 9 halves times 4 is going to leave me with a what? 18. Isn't that a prettier equation? So if you don't like the fractions, get rid of them in the equation. So I can subtract the 9 on both sides, so I end up with 8x to the third is equal to 9. Then what? Divide by 8. X to the third is equal to 9/8. So what's x going to be equal to? Cube root of 9 over 2, because the cube root of 8 is what? 2. Yes, it's not a pretty x coordinate, but this original equation wasn't pretty, so don't expect things to be pretty. All right? So now I know my x coordinate, I know my y coordinate, so now I can go ahead and I can plug in, I can write my answer as an ordered pair. Cube root of 9 over 2 and 3 halves. Questions on that? So sometimes you're going to have to do the second derivative using implicit differentiation. Go ahead for me in example 4. Find the first derivative for me. Then we'll do the second derivative together. Go ahead and do the first derivative for me.